Okay, so we're going to look at page 291, number 5. Number 5 says each of the following vector expressions can be simplified and written as a single vector. Write the single vector corresponding to each expression and illustrate your answer with a sketch. Okay, so we're going to look at 5a, which is PQ minus RQ plus RS. So PQ. Okay, so let's take a look at this. So page 291, number 5a, which is PQ minus RQ plus RS. Okay, in order to figure out what this looks like, we're going to draw a diagram. So pick 4 random points, P, Q, R, and S. So P, Q, R, S. Okay. And I'm going to draw the vector PQ. There's PQ. And then negative RQ. So RQ is this way, so negative RQ is going to go that way from Q to R. Okay, so that's negative RQ, and then plus RS. So that one is RS. The resultant vector is from the starting point when we're doing this tip to tail method, from the starting point all the way to the final point. Okay, so the resultant there is then PS. Okay, so when you follow this expression, you're going to end up with PS as the solution, the resultant. Algebraically, if you want to look at this, so PQ minus RQ plus RS equals PQ plus QR. Okay, so I'm rearranging the minus RQ to plus QR, and then plus RS. And in this, when you go from P to Q and then Q to R, you're really just going from P to R. So these pretty much cancel out. So if you go from P to Q, then Q to R, and then R to S, well, the R's cancel out too. As long as they end and start with the same letter, you can get rid of them. You end up with PS. Same result as if we drew it. Okay, 5B. 5B is PS plus RQ minus RS minus PQ. Okay, so I can put out those same dots in the same spot. Okay, so something like this. P, Q, R, S. And then PS plus RQ. Well, let's draw PS. There's PS. Plus RQ, well, I would have to translate that vector RQ up to the end point there and draw it like this. That's okay. But I could put this in a different order, and instead of putting RQ at the end of PS, I could use this one here, negative RS. Negative RS, so there's RS, negative RS is this way. Okay, so that's negative RS. So I go P to S, then S to R, okay, then R to Q, and then the last vector is negative PQ. Well, PQ is from P to Q, negative PQ is Q to P. Okay, so there's all those vectors put together, and it ends up where I started from. So this ends up being the resultant in this one. The resultant equals the 0 vector. Okay, because you don't move anywhere as a result. You end up back in the same spot. If you want to look at this algebraically, so PS instead of, so plus RQ minus RS minus PQ can be rewritten as PS, and I'm going to take this minus RS and turn it into a plus SR, and then I'm going to put the RQ in there, okay, that one, and then I'm going to put plus QP. Okay. In this way, they always end and begin with the same letter, so I can cancel them out. Cancel out the S's, cancel out the R's, cancel out the Q's, and I have vector P, P. And from point P to point P, you haven't moved, so that is equivalent to the 0 vector. And that's number 5 from page 291.